This video is sponsored by Hetzner. If you're hosting your apps using Coolify and you're ready to scale beyond one server with zero downtime deployments and high availability, then this is the video that finally explains everything from the start to end. Before we start, I want you to know the beginning of this video might feel like a lot of information, but don't worry, I will guide you step by step, and everything will make sense. Most Coolify users run their application on a single server, one machine that hosts Coolify, their application, and runs the database. This setup works perfectly fine for small projects, but as an application grows and traffic increases, a single server becomes a bottleneck. It limits available resources and creates a single point of failure. To scale reliably, we need to move beyond the one-server setup. We can start by moving the database to its own server. This separation keeps the database unaffected by issues on the application server and allows database to scale independently. Coolify can still manage both the app and the database from the same dashboard, whether you're hosting the database yourself or using providers like PlanetScale or Supabase. For this video, I will assume the database is self-hosted. As the application grows, the next step is to move the app to its own server. This gives each part of the stack the resources it needs, while still keeping everything manageable through Coolify. Eventually, we'll reach the point where increasing a single server's resources isn't enough. When that happens, we'll need a high availability setup, running the application across multiple servers to keep scaling smoothly. In a high availability setup, we run the application on multiple servers and place a load balancer in front of them. Our domain points to the load balancer's IP address, and the load balancer distributes traffic across the app servers. All servers are still managed from Coolify, and Coolify handles deploying the application to each one. If one of the app servers goes down, the load balancer stops sending traffic to it and routes requests only to healthy servers. It continuously checks the health of the application on each server and decides whether a server is ready, based on the health check responses. The load balancer tracks the health status of every server, but this can lead to a common issue. During a new deployment, a server might receive traffic before it's fully ready. I'll explain the solution for that in a few minutes. We can also add Cloudflare for DDoS protection and caching. In this setup, our domain points to the load balancer, and Cloudflare's proxy is enabled, keeping the load balancer and all servers hidden behind Cloudflare. I'll show how to set this up at the end of the video and include timestamps in the description. Coolify helps a lot with high availability, because we can use the Coolify dashboard to access all of our application servers and databases, and let Coolify handle automatic deployments across multiple servers. Before we go further, I want to explain how multi-server deployments work and how we achieve zero downtime deployments using Coolify. Without this foundation, the rest of the tutorial will be harder to follow. When an application is deployed to more than one server, Coolify assigns one server as the primary and the rest of the servers as additional servers. At this stage, all servers are running version 1 of the application. When we deploy a new version, Coolify starts with the primary server. It builds the application on the primary server and pushes the resulting Docker image to a Docker registry. All additional servers then pull that image, so the build happens only once. You can use a dedicated build server or even build through GitHub Actions, but for this video, we'll build on the primary server. During the build, the primary server continues handling incoming requests, so both the build and the live application run side by side. If the build fails, Coolify simply leaves the server running the existing version without interruption. Once the deployment on the primary server completes successfully, Coolify deploys the new version to all additional servers at the same time. This way, there is always at least one server available to handle incoming traffic. We need to understand how traffic switches to the new container during a deployment. Here we have our application server running version 1 of the app inside a container. When version 2 is deployed, it runs in a completely new container. Docker stops the version 1 container first and then starts the version 2 container, which creates roughly 10 seconds of downtime. If the load balancer isn't aware that a deployment is happening, it will continue sending traffic to the server during this window. I'll show you how to solve this issue later in the video. During the deployment, Docker sends a SIGTERM signal to the version 1 container with a 30-second grace period. SIGTERM tells the container to shut down its processes cleanly within that window. If it doesn't stop in time, Docker sends a SIGKILL signal, forcing it to shut down immediately. Once version 1 is fully stopped, Docker starts a new container based on the version 2 Docker image, and that container begins handling all incoming requests. Some applications exit immediately when they receive SIGTERM, so we need to set up our own health check endpoint and make the shutdown process predictable, usually around 20 seconds after SIGTERM is received. While the application is running normally, the health check endpoint should return a 200 status code. The moment the app receives SIGTERM, the health check should switch to returning 503 service unavailable, then exit after about 20 to 25 seconds. This lets the load balancer know the application is shutting down and should not receive new traffic. The fixed delay gives the load balancer time to detect the state change and allows the application to finish processing any in-flight requests during that period. For multi-server deployments with zero downtime, there are 5 rules you must follow. If even one is skipped, the setup won't work properly. First, your application deployment on Coolify cannot use Docker Compose. Coolify doesn't support deploying Compose-based applications across multiple servers. Second, Coolify builds the application and pushes the image to a Docker registry, and the additional servers pull the image from that registry. This means you must be logged into the registry on every server where the app will run. You can use any registry such as Docker Hub, GitHub Container Registry, or others. In this video, I'll be using Docker Hub. Third, your application should not rely on a volume for persistent storage. Coolify doesn't allow multi-server deployments when volumes are involved, though I'm not entirely sure why this limitation exists. Fourth, the application needs a custom health check endpoint. Without it, the load balancer may continue sending traffic to a server while it's not ready, causing users to see 503 service unavailable responses from the load balancer. Fifth, your domain has to be managed by load balancer provider. I'm using Hetzner servers and a Hetzner Load balancer in this video. If you're using another provider, make sure their load balancer can terminate TLS and renew certificates automatically. And if you plan to place Cloudflare in front of the load balancer, then the domain must be managed by Cloudflare, and you'll need to configure a Cloudflare origin certificate on your load balancer. I'll show how to set that up at the end of the video. Now that we've covered the technical details, I want to talk about the sponsor of this video, because they literally made this entire video possible. A huge thanks to Hetzner for sponsoring this video and covering all the service costs throughout the 4 months I spent preparing this video. I personally use Hetzner for all of my production workloads. Hetzner is reliable, affordable, and offers far more value compared to providers like DigitalOcean or Linode. For example, around $29 per month, you can run 5 low-cost servers plus a load balancer, giving you a combined 10 virtual CPUs, 20 GB of RAM, 200 GB of disk space, and each server includes 20 TB of outbound traffic at no extra cost. When you compare that to DigitalOcean or Linode, you typically get about half the resources for a higher price. If you're looking for a reliable and affordable cloud provider, you can check out Hetzner using the link airflare.com/Hetzner. In this tutorial, we will be deploying a full-stack Next.js application with a database. We can add and delete records from the database, which is just a name in this case. I will be deploying this application using a Docker file, because Coolify doesn't allow deploying Docker Compose-based applications on multiple servers. I'll quickly go over the Docker file, and I've included link to the codebase in the video description so you can follow along if you want. I'm using Bun 1.2 Alpine as the base image, setting the working directory to /app, updating the packages, and installing OpenSSL, which is needed for Prisma. Prisma is just an ORM we use to interact with our database. Then we'll copy the package.json and bunlock files, install all dependencies using bun, and copy all of our source code into the Docker image. Next, we generate the Prisma client using bun Prisma generate. After that, we build the application, expose port 3000, and set the host environment variable so the application listens on all network interfaces. If you skip this step, you won't be able to access the app from outside the container. We also set node environment to production and use bun Prisma migrate deploy followed by bun run start to start the app. The Prisma migrate command makes sure all database migrations are applied. For environment variables, we only need the database URL to connect to the database. Now let's talk about the health check logic in the Next.js application. If this isn't set correctly, some requests may fail during deployments. I have a health module with the core health check logic. We import Prisma here, you'll see why in a bit. I've set a variable is shutting down to false. This variable keeps track of the application state. False means the server is not shutting down. When the application process receives a SIGTERM signal from Docker, it logs the signal to the console and sets is shutting down variable to true. Then we have a function that checks the value of this variable. If it's true, the function returns a 503 status code with a service unavailable message. If is shutting down variable is false, the function runs a simple query on the database using Prisma. If the query executes successfully, it returns a 200 status code. If there's an error, it logs the error to the console and returns a 503 status code with a service unavailable message. This logic makes sure our app is only considered healthy if it can access the database without any issues. We also have a health API route in the app, which the load balancer uses to perform health checks. Here, we get the health status and message from the check health function in the health module. We also send additional headers for cores and connection set to close. This tells the load balancer to close the connection after the health check, preventing false positives where the load balancer might think the app is healthy when it's not. Finally, we have our custom server.js. This is a full-stack Next app with a custom server because the default Next server doesn't support everything we need. Here, we check if a port environment variable is set. If it isn't, the server defaults to port 3000. When Docker sends a SIGTERM signal, the server logs it and continues accepting requests for the next 25 seconds while the health check returns 503 status code, then stops accepting new connections and exits. If the app receives a SIGINT signal, it exits immediately. That's the complete health check and shutdown logic, which makes zero downtime deployments possible. For this video, I've already set up a few things in advance, so let me quickly walk you through them. First, I created a new server and installed Coolify on it. Once Coolify was ready, I moved my DNS management over to Hetzner. On the Hetzner dashboard, I created a new DNS zone by clicking the Add DNS Zone button. I entered my domain, selected Create an Empty Zone, then went to the Name Servers tab and copied the 3 name servers provided by Hetzner. After that, I updated my name servers on GoDaddy, which is my domain registrar. On the GoDaddy dashboard, I opened the Name Servers section, clicked Change Name Servers, selected Use My Own Name Servers, and pasted in the Hetzner name servers. The propagation took about 30 minutes. If you prefer using Cloudflare for DDoS protection and caching, then you should use Cloudflare's name servers. I've already made a separate video explaining how to set up the Cloudflare for DDoS protection, and I'll include the link to that video in the description. Once the name servers had propagated, I added a new A record for the Coolify subdomain and pointed it to the server IP where my Coolify instance is running, so I can access the Coolify dashboard using my domain. Then I set up a GitHub app so Coolify can deploy applications directly from private repositories in my GitHub account. I've already made a separate video explaining how to set up the GitHub app, and I'll include the link to that video in the description. First, we need to create a private network on Hetzner. To do that, go to the Networks page from the sidebar and click the Create Network button. This allows us to place all of our servers inside a private network so they can communicate with each other internally. This also means our servers and database won't be directly accessible from the internet, which is important for security. I'll give the network a name and select a network zone. Your servers and networks has to be in the same zone. In my case, that's EU Central, because I'll be creating my servers in Germany. For the private IP range, I'm using the default 10.0.0.0 with a 16 range. The lower the number after the slash, the more private IP addresses you can allocate within the network. After creating the network, Hetzner automatically creates a new subnet with a 24 range. The 16 range defines the entire network, while the 24 range is the subnet that our servers will actually use. Now that our private network is ready, let's set up the load balancer. Go to the load balancer page from the sidebar and click on Create Load Balancer button. For the location, I'm choosing Nuremberg, which is in Germany and part of the EU Central region. And for the type, I'm picking LB11, which is the smallest load balancer on Hetzner. It supports up to 10,000 open connections, so it's more than enough for what we need. Next, I will select the private network we just created, so Hetzner will add this load balancer to our private network. Next, we have targets, which are the servers that the load balancer sends traffic to. We haven't created our application servers yet, so we'll just skip this part for now. Now let's set up our service. Services are basically your applications. You can route multiple apps on the same load balancer, like one on port 3000 and another on port 8000. But in this video, we only have one service, which our Next.js app, which runs on port 3000. Set the protocol to HTTPS. It'll automatically set the source port to 443. Then set the destination port to whichever port your app uses. For me, it's 3000. So with this setup, we're basically telling the load balancer, if someone visits our website on HTTPS port 443, send that traffic to port 3000 on the backend servers. Make sure to turn on the HTTP redirect option. This makes the load balancer automatically redirect any HTTP request to HTTPS. Next, we need to set up our SSL certificates, because the load balancer is handling HTTPS for us. Click on Add Certificates. Here you can either create a certificate automatically or upload your own. If you're using Cloudflare, you'd upload a Cloudflare origin certificate here. But I'll let Hetzner handle everything for me, so I'm selecting Create Certificate. I'll name it Tutorial. The name is just for display, so you can choose anything. Then select your DNS zone. I only have one, so I'll use that. Now we tell Load Balancer which domains to generate certificates for. Enabling this first option creates a certificate for the root domain, in my case, aeroflare.cloud. Then for subdomains, you can enter something specific like Coolify. But I'll keep it as an asterisk, because that gives me a wildcard certificate, which covers all subdomains of aeroflare.cloud. After that, click Create Certificate. Hetzner will generate it in the background, but we can continue while that happens. Next is health checks, and this part is extremely important for zero downtime deployments. Set the protocol to HTTP, because inside our private network, the load balancer talks to the application servers using plain HTTP. Set the destination port to 3000, or whatever port your app runs on. For the interval, I'm using the minimum, which is 3 seconds. Then set timeout to 1 and retries to 1. These are very aggressive settings. I'm only using them for this video. In production, you should experiment with this to avoid false positives. If your app needs a host header for the health check, you'd enter the domain here. Mine doesn't, so I'll leave it empty. For the path, I'll enter /API/health, because that's where my app exposes its health check endpoint. I'll keep the response field empty. The default works fine, and any 200 or 300 status code will mark the server as healthy. Keep TLS disabled because health checks use HTTP. Session stickiness, you can turn it on if you want user's session to be handled to the same server, but I don't need it, so I'll leave it off. And I'll keep proxy protocol off as well. Enable this if you want the load balancer to pass the client's information, such as IP address, to your application server. Now for the algorithm, Hetzner gives us two options. Round robin, which distributes traffic evenly to all servers, and least connections, which sends new requests to the server with the fewest active connections. Both works, but I'll choose round robin. I'll skip labels since we don't need them. Give the load balancer a name and click Create and Buy Now. All right, our load balancer is now ready. It has a public IP, and it also has a private IP inside our private network. Servers inside the network will communicate with it using that private IP. Now we need to point our domain to the load balancer. So I'll copy the public IP, go to my DNS settings, and create a new A record. For the name, I'll enter the @ symbol because I want to use the root domain, aeroflare.cloud. If you wanted a subdomain, you'd enter it here instead. Paste the load balancer's public IP as the value and save it. Now if I visit the domain, I get a 503 status code that says no server is available to handle this request, which is totally expected. The load balancer is online, but we haven't connected any application servers yet. And that's exactly what we're going to do next. Before we create our application servers, we have to set up a few things that will make the whole process easier. First, we need to add our Coolify server to the private network. So I'll go to the Networks page and open the network I created earlier in this video. Then, I'll go to the Subnets tab. Here we can see our load balancer with a private IP that ends with 2. Hetzner added it automatically because we selected the private network option while creating the load balancer. Click Attach Resource, select the option server, then choose the Coolify server. I'll enable the option to set a custom IP because I want the Coolify server to have an IP ending with 3. Now I'll click Add Servers. Next, we need to set up SSH keys for the application servers. So I'll go to my Coolify dashboard, and from the sidebar open the Keys and Tokens page. That takes us to the Private Keys tab. I'll click the Add button to create a new key. Then I'll generate a new key by clicking this button and rename it to App Server Key. The name is only for us to recognize what the key is for. Now I'll copy this public key, because we need to add it to Hetzner so that Hetzner can automatically add it to the new servers when we create our application servers. On the Hetzner dashboard, I'll go to the Security page from the sidebar and open the SSH Keys tab. Then I'll click Add SSH Key, paste the public key I copied from Coolify, rename it to App Servers, and click Add SSH Key. For this video, I'm using a single SSH key for all servers, but for production, you should use different keys for security. Next, we have to set up a firewall. Go to the Firewall page from the sidebar and click Create Firewall. I'll name the rule Private Network and set the IP range to our private network. I'll keep the protocol as TCP and set the port to any, so the rule covers all ports. I'll leave everything else empty and give the firewall a name and click Create Firewall. Next, we have to set up our Docker registry. I'll be using Docker Hub for this video. I want the Docker image for my application to be in a private repository. So to push and pull images from a private Docker Hub registry, our application servers need an access token. So on Docker Hub, I'll go to Settings, then Personal Access Tokens. Then I'll click Generate New Token. I'll give the token a name, set the expiration date to 30 days, and set the permissions to read and write. Because Coolify will build the Docker image and push it to the registry, so we need write permission to the repository. Now I'll click Generate, and Docker gives us a new access token. I'll copy the token and save it somewhere safe. Next, I'll create the application servers. On Hetzner dashboard, go to the Servers page from the sidebar and click Add Server. I'll choose the server type cost-optimized ARM64, then choose the CAX11 instance. For the location, I'll choose Nuremberg, which is part of EU Central. Then I'll select the operating system Debian 12. Debian 13 is still new, so I use Debian 12 most of the time. For the IP address, I'll disable IPv6 and enable private networks, then select our private network. You can use only the private network, but having a public IP is helpful to directly access the server whenever we want. And I disabled IPv6 because not many services use IPv6, so it has no use for me. Next, I'll select the SSH key we created earlier from Coolify. I'll skip the volumes since I don't need it. Then I'll select the firewall we created earlier, so when this server goes online, it won't be exposed to the internet. I'll skip backups and create a new placement group. What this does is spread our cloud servers across different physical servers. So if one physical machine goes offline or has hardware failure, the other cloud servers won't be affected. I'll skip the labels. Now we have the Cloud Config section. This is a very helpful feature because it lets us automate some of the manual work we would normally have to do, like logging into Docker Hub on all the servers running our application. We can automate this using Cloud Config. I already have a Cloud Config ready, and I'll leave a link to it in this video description. This config will automatically update our packages, install curl, install Docker, and then log into our Docker account. Here we just need to add our Docker access token inside these quotes, which we created earlier. Now I'll increase the server count by clicking the plus icon. We're going to buy 4 servers, 1 server for the database and 3 servers for the application. I'll give each server a name and click Create and Buy Now buttons. Now we wait for Hetzner to provision our servers. This takes less than 10 seconds, but I'll give it up to 2 minutes since it has to install Docker and update all packages. In the meantime, we can check our private network to see if the servers are added. All of our servers and the load balancer are in the same private network with their own private IP. We'll use these IP addresses in Coolify to connect the servers. Now that our application servers are ready, let's add them to the load balancer. I'll go to the load balancer page and select our load balancer. Here you can see it shows 0 targets, and the health status also says no targets. So I'll go to the Targets tab and click Add Targets. Choose Cloud Server, select all of our application servers, choose their private IPs, and click Add 3 targets. The load balancer checks the servers using the health check we configured earlier, and it shows that the servers are failing the health check. This is completely expected since we haven't deployed our application yet. Now let's connect all of our application and database servers to Coolify and deploy our application and database. I will go to the servers page so I can see private IP addresses of all of our servers. Now I'll go to the Coolify dashboard and add each server using its private IP address. I will go to the servers page from the sidebar and click the Add Server button. For the database server, I'll use the same SSH key I generated for the app servers. Hetzner automatically added this key to the database server when I created the servers, so Coolify can use that key to access the database server. Next, I'll click the Validate button, so Coolify will SSH into the database server and install all the necessary packages. I'm using the private IP here because all of our servers are on the same private network, which allows them to communicate with each other internally. If you're not using a private network, then you'll need to use the public IP address of the servers. For this video, I'm using a single SSH key for all servers, but for production, you should use different keys for security. By default, Coolify will start the proxy and Sentinel services, but we don't need those for this setup, so I'll go ahead and stop the proxy and disable Sentinel on all servers as I add them to Coolify. With the database server now connected to Coolify, we're ready to deploy anything to it. But before we deploy, I will add all our application servers the same way I added the database server. I will speed up the video here since it takes around 2 to 5 minutes to add all the application servers, and I don't want to waste too much of your time. Now we have all of our servers connected to Coolify. Let's deploy our database to the database server. I already created a project for this video called Tutorial, so I will deploy the database on that project. In Coolify, projects are just a visual thing, so it doesn't matter which project you deploy the database and applications on. I will deploy Postgres from the one-click database list since a lot of things are pre-configured on it. But you can deploy your database from your custom Docker Compose file from Git repository or any other way Coolify supports. I will choose the database server and select the Postgres 17 as the database. We have to map the ports of the database to the host server, so that our application servers can access this database using the private or public IP of the database server. Since we have a firewall that only allows the traffic on the private network, this database won't be exposed outside the private network. So mapping port while having the firewall set to private network is safe. In the port mapping field, I will enter 5432:5432. The port on the left side of the colon is the port on the host server, and the port on the right side is the port of the database. So when we connect to this database from the application server, we have to use the port on the left side, which is 5432. Now I will deploy the database by clicking on the Deploy button. I will leave all the settings as default for this video, but you can change or adjust the settings based on your needs. Now our database is deployed. Let's deploy our applications to the application servers. I will create a new resource and select the option Private Repository with GitHub app, because my application codebase is in the private repository, and I already set up a GitHub app on this Coolify instance. I have a tutorial video to set up this GitHub app, so I will leave a link to that video on this video description. I will select the app server 1 and then add other servers as additional servers later, so the app server 1 will be our primary server. I will select my GitHub app so that I can use it to access my private repositories. I will select build pack as Docker file and set the base directory to /, which is the root of the repository. I will rename this app to Next.js app and set the domain to airflare.cloud, which is the domain I want to deploy this app on. You can use your subdomain or any other domain, but I will use the root of the domain, which resolves to the IP of the load balancer. Now we have to enter a Docker image here. This is for Coolify to build the Docker image for application and push it to the Docker registry using this image name, so that our other application servers will pull this Docker image from the Docker registry and deploy new version of our application. I am using Docker Hub for this video, so I will create a new repository on Docker Hub. From the sidebar, click on Hub, then click on Repositories. I will give the repository the name Tutorial and set the visibility to private and click on Create button. Our private repository is now created, so we have to use this image name on Coolify. I will set the image tag to latest. You can leave it empty, but I will use latest. This app needs to connect to our database, so when I built this app, I added a variable called database URL, which our application will use to connect to the database. So first, I will get the value of the database URL from the database we deployed using Coolify earlier. The database URL is this internal PostgreSQL URL, so I will copy this internal URL and go back to the application configuration page to add the database URL environment variable. I will give the name as database URL for the variable because this is what I set on my application codebase for database connection. Then I will paste the internal Postgres URL I copied from the database page. On this database URL, we have to replace the hostname with the IP address of our database server. So the hostname is after this, @symbol. So I will replace this with the private IP of the database server. I will quickly check on Hetzner dashboard for the IP address of this database server. I will copy this and replace the hostname with this IP address. I will enable available at build time and runtime options and save the variable. Our next application uses Prisma as the database ORM, which needs to access the database during the build time. So we have to enable the build time and runtime options. Now we have to map the port of the application to the host server. So scroll down until you see the network section and set the port mappings. I will set 3000:3000, so the application will be accessible on the server's IP with port 3000. The reason why I use 3000 is my application listens on the port 3000, so if your application uses different port, then use that port here. Now I will add additional service to this application, so I will click on Servers and click the app server 2 and 3 here. So server 1 is a primary server, and 2 and 3 are our additional server. So the deployment first happens on the server 1, which is our primary server. Coolify will build the application on the primary server and then deploy it to additional servers using the Docker image, so I will click on Deploy button. Here you can see the deployment started on application server 1. If you don't want to build the application on primary server, then you can either use a dedicated build server or build the app using GitHub Actions. Let me know in the comments if you want a tutorial video on it. The deployment will take some minutes depending on the server capacity. This is a Next.js app, and the server I have is very small, so it will take some time. I will speed up the video until the application builds. Here you can see the application is built, and Coolify is pushing it to the Docker registry we set earlier. So once the Docker image is pushed to the registry, Coolify will deploy it to the application server 1, then trigger the deployment for application server 2 and 3. Here you can see Coolify is now deploying our application to server 2 and 3. This will take less time than deploying on server 1, because the image is already built, so it will just pull the Docker image and start a container based on that image. If one of our server is not running the application, then Coolify will show the status as degraded or unhealthy. You can completely ignore this, and the health status shows unknown. We are not setting up any health check on Coolify, so you can ignore it as well. Now our application is deployed on all servers. You can confirm this by going to Servers page. Here you can see the green dot next to the server name. This means the application is running on this server. Let's check our load balancer on Hetzner to see if the health check now passes for our application. Here you can see the health status now shows as healthy. We can go to the Targets tab and see the status of each of our application servers. Now let's visit our website to see if the application is accessible. Our application is running successfully. You can see it is connected to the database. So let's add some name on this people list and see if it saves on our database. Here we can see the total row number is 2, which is the same amount of name I added to the people list, so our data is stored on the database. Next, I want to show you the zero downtime deployment for this application. I have built in different application to monitor the request success rate for this application. So first I will deploy that, then I will push a change to GitHub for this application, so Coolify will redeploy the new version of application without any downtime. I am deploying this test app on the server, which is running Coolify. While Coolify deploys this app, I will add a DNS record for this app on our Hetzner DNS. Since the test app is running in Coolify server, I will create a new A record for the subdomain tester and use the same IP address of Coolify server. Now the tester application is deployed. I will visit the tester app site. Here I will enter the URL of our Next.js application and start pinging the website every 1 second. So here we can see the status of request every second and the success rate based on the number of requests getting 200 status code. Now I will merge a pull request on the Next.js application codebase on GitHub. So Coolify will deploy the new version of our application. While it deploys, we will check this tester site for the status of the request we are sending. Coolify started deploying our new version of the application on the app server 1. So currently it is building the application. Then it will push it to the Docker registry. While it deploys, we will check the health status of the service from the Hetzner dashboard on the load balancer page. See, the app server 1 went down during deployment, but all requests are receiving 200 status codes on our tester site. Keep watching the status of app server 2 and 3 because they will go down during the deployment, so we will check the tester site for the success rate of our requests. See, during deployment there is no downtime. All the requests sent to the domain were receiving 200 status code. This is how you achieve zero downtime deployments and high availability using Coolify. Next, I will show how you can put Cloudflare in front of the load balancer for DDoS protection and caching. First, go to your Cloudflare dashboard and open the DNS page for your domain. Here you need to add a new A record or update your existing one so that it points to the public IP address of your load balancer. Make sure the Cloudflare proxy is enabled. This means your domain will resolve to Cloudflare's IP addresses instead of exposing the load balancer directly. Next, we need to create an origin certificate. Go to SSL/TLS in the sidebar, then open the Origin Server section. Click Create Certificate button. For the private key type, select RSA. Choose the hostnames you want the certificate to cover. Then set the validity period to a long duration, like 15 years, and click Create. Cloudflare will now generate an origin certificate and a private key. Keep this page open, because we need both of these for the load balancer. Now go back to the Hetzner dashboard, open the Load Balancers page, and click on your load balancer. Then go to the Services tab and edit the service. Click Add Certificates, select Upload Certificate, and paste the certificate and private key you generated in Cloudflare. Finally, go back to the Cloudflare dashboard and go to SSL/TLS Overview page. Make sure the encryption mode is set to full or full strict. If it isn't, click Configure and change it. And that's it. Your load balancer is now behind Cloudflare, giving you DDoS protection and caching benefits. That's it for this video. A huge thanks to Hetzner for sponsoring this video. And if you have made it to this far on the video, then leave a nice comment and check out Hetzner using the links in the description. It helps the channel a lot. See you on the next video.